Okay, 7.5a, solving exponential equation. What do you think 7.5b is going to be?
Well,
What undoes exponential
something a lot.
log equations?
Yeah.
All right. So we have some exponential equations. We have 4 to the 3x equals 8 to the x plus 1. Now, these are powers, so these are exponents, right? 3x and x plus 1. How do we undo exponentials? How do we do what undoes exponents?
No.
Logs. Okay, so we have a problem though, because our bases of the power are not the same, are they? Here's where you're going to have to use your brains. Sorry, I'm really sorry. You're gonna have to do some thinking. All right, and here's what I mean by thinking. Think. How can I make a 4 and 8 into the same base? What do you mean by multiplying by 2? How can I rewrite 4 as a 2? How can I rewrite 4 as a base of an exponent using the base 2? Like what? Like what? Not 4. 2 raised to the second. What about 8? How can I write 8 as a base 2? 2 raised to the third. Okay, let's fill in the rest of the stuff here, okay? All right. I need my equal sign. What else do I have with the 4? So I have to raise this to the 3x, right? What am I raising this to? X plus 1. Now I have a power raised to a power, right? What do I do with powers raised to a power? The thingamajig. The thing we did last Thursday. I don't even know what I did this morning. What did we do last Thursday? Huh? Multiply the exponents. Think of it as distribution, right, over the parentheses. So I have to take 3x times 2. So what do I get? 2 to the 6x. And when I take x plus 1 times 3, what do I get? X to the third plus, what? I don't know. 3x plus 3. Okay, there you go. I almost yelled at, I thought you were Nathan that said that, so I was about ready to yell at you. Okay, now what? Now what happens here? Now I can get rid of the base 2, right? Just take what does undoes logs. Does it matter which log I take? Log base 2 of both sides, right? So it cancels out that 2. And what am I left with? Okay. What does x equal? 1, right? Subtract 3x from both sides. I get 3x. I get 3x equals 3. Divide both sides by 3, and x equals. Wasn't too bad, right? Somebody in this class have music on, or is that? Huh? Who? Is that Talia? Huh? It's in the hallway, right? Nobody would be playing music while I'm talking, right? That's right. Okay, let's do the same thing with number 2. What's going to be a common base here? 2. I don't have to worry about this one, do I? How do I make 32 into a base 2, Greg? What's 2 squared? It's not 32, is it?
Oh, you're talking about
2 to the 16.
no. Oh, okay. All right, I'll figure it out.
What is it?
2 to the 5th.
2 to the 5th.
2 to the 5th.
2 to the 5th. Okay. Keep multiplying 2 and count how many times you have to multiply to get to 32. Okay. All right, so we have this 2 to the 4x, and we have this 2 to the 5th to what? X minus 1. Good. Okay. These equal each other. Nothing I'm going to do here, right? I still have my 2 to the 4x. What about this side?
Yeah.
Distribute 5. What do I get?
5.
Good. Now, I could put the log base 2 in here, but what's going to eventually happen to these two? And I end up with and what's my answer?
Negative 1 over 5.
Negative 1x equals negative 5. So what does x equal? Okay. How about number 3? What's going to be my common base here, my lowest? 4 times what? 4. I'm going to multiply 4 how many times to get 8? So 4 times 4 is 16. How do I get 8? I use 2. That's what. Okay. 2 and 2. 2 how many times is going to give me 8? 2 how many times is going to give me 16? Okay. So let's fill in everything else now. I have my 5x equals, I have my 3x plus 4. Okay. Let's go on. 2 to the what now? 15x. 2 to the 4 times 3x plus 4. What's going to happen to my 2's? So I end up with okay, 15x minus 12x.
Yeah.
So I end up with 16 divided by 3, right? Everybody getting this? Who wants to? How about number 4?
I'm sure we can.
Okay, 2 times itself, how many times to get me 6? 2 times 2 is 4, times 2 is 8. No?
No.
3s?
Yeah, I know.
How many 3s will get me 6? Okay, so 3 times 3 is 9, so 3 doesn't work.
Yeah, but
Huh? Keep it at 6. How many times do I multiply 6 to get me to 16?
wait.
3 times. I heard Blake earlier. Okay, let's fill in everything else now. I have my 2x minus 7. Well, you know, there's nothing. 6 is not a perfect square.
Oh, the yellow sheet.
Yellow sheet, because I got that in front of me and I'm looking at it. Okay, so 6 is not a perfect square. It's a very low number, so I have to use 6 for my base. And hopefully 216 is divisible by 6. All right, so I have no exponent there. So I'm going to take so I could just leave everything the same, right? Nothing to multiply, they're just 1. So I have 2x minus 7 equals 6 to the third. My 6's are going to what? Go away. So I get 2x minus 7 equals 3. Add 7. 2x equals 10. So what's x? Easy peasy, right?
That's fine.
As soon as you what? Yeah, the hardest part is coming up with the base.
Now it's gonna get extra hard.
Now, of course, it's going to get harder.
Oh,
All right, so parts 2 and 3, it says taking a logarithm of each side and then round your answers to the nearest thousand. So how many decimal places? That's right.
10.
3. 3 decimal places.
10. 100.
Okay. How do I do this one? What's going to be my base?
Oh.
Oh,
That's
oh my gosh. So how many times am I going to multiply 2 to get 7? Yeah, we have a problem, don't we?
oh, log 10.
Use log. Okay, let's use common log. All right. Very good. I'm going to use common log of both sides. And why am I going to use common log of both sides?
Because
Why did you pick common log?
they're gonna have an
Well, I mean, we could have taken natural log. We could have used, but was that just a lucky guess?
well, because there's no, it's not divisible, so
Yeah, our bases does not have a common base, right? So the next natural thing to do is to take a log of both sides. But the common log base 10 was a good choice because looking at your calculators,
right to your butt.
yeah, that's crappy. I'll just use one of your crappy ones. In the log, it's 10. Guess what? I have a common log key on my calculator.
Really?
So that was a great choice. Okay? Now, I can't take the log of 2x, 2 to the x, but I can do something with that x. What can I do? What can I do with that x? You just did your homework on it. Huh? Undo it how? What is the x? What's that called? exponent. What do I do with exponents if I want to expand them? Put it in the front. Okay. So I get x log of 2 equals log of 7. Okay. Now there's multiplication between here, right? How do I get x by itself? Divide by log 2. Divide by log 2. I can do this in my calculator because we have a common log key. So x is going to equal, let's see, log 7 divided by log 2. Enter. And how many decimal places, Nate? 3. 2.807. Good job. Good job, Greg. As much as I insult you and sarcastic to you, every once in a while, even a blind squirrel finds an acorn. All right. Number 6. I have to find x, right? What am I going to do first here? If I have x plus 4 equals 21, what do you do first to solve for x? Subtract it, right? So I'm going to subtract the 4. Okay, so I get my x term by itself. I get my 10 raised to the 2x minus 3 equals 21 minus 4 is 17. Now I could do, move this out in front or something, but what did we do up on the problems up here? Even this problem. How did we get rid of the base, this base 10? Greg did it. Remember he found that acorn? Yeah, because it's log of both sides, right? And I'm going to use the common log because what's the base of the common log? 10, right? Okay, so that cancels out the 10, and I'm left with 2x minus 3 equals log of 17, right? Okay, now how do I get x? Well, I got to get x by itself. So what am I going to do? Add 3 to both sides. And then I'm going to divide the whole thing by 2, right? With me, I'm doing 2 steps at once. So my x is going to equal, now, be careful with fractions. Do your numerator first, hit enter, then divide by 2. Okay, so we're going to take log of 17 plus 3, hit enter, then divide by 2. And I get 2.115. All right, let's do number 7. What do I do first? Subtract 3 from both sides. So I get e to the 2x equals 5. How do I get rid of the base e? Take the natural log of both sides. Because the natural log gets rid of the base e. So I'm left with 2x equals ln of 5. And what am I going to do? Divide by 2, divide by 2. I can do this in my calculator because I have a natural log key. So I have the ln of 5. You could either hit enter, but because we only have the one term, you could divide it by 2 right away. 0.805, right? Got around it. Number 8. 2 to the x plus 3 equals 25. I got to get rid of the bases 2 and 25. There's no common base for the 2 because 25's only got, can only be 5. So we're going to have to either use log. You could use natural log too. The thing about natural log, unless you've got a 10 base like this one, natural log will work on all the problems. Except for when you have a base 10. Okay? So I have ln of 2. I'm not going to have a choice. What am I going to have to do with this? Yeah, I'm going to have to move this to the front, right?
How do you know that?
How did I know that? Because I could take ln of 2. You're going to end up dividing both sides by the ln of 2. Because there's nothing I can do with that x plus 3. So I'm actually going to put it out in front because it's easier to understand teaching you guys. Because we did that. My x plus 3 goes in the front using that property. Ln of 2 equals ln of 25. That's more understandable. Okay, I'm moving the exponent to the front. There's multiplication between these two, right? So what am I going to do with the ln of 2? Divide it so that I can get x plus 3 by itself, right? Huh? You could. You could use log. So I get x plus 3 equals ln of 20. Well, let's go ahead and figure what that is. Ln of 25 divided by ln of 2. Okay. And then I'm going to do what? I'm going to subtract 3 from it, right?
Oh.
So we might as well just subtract 3. And there's my answer for x. You want to write this out, it's 4.644. And then we're going to subtract 3, so x equals 1.6. How about we stop here?
Sounds great.
Tell you what, why don't you guys work on four problems? Work on 9, 10, 11, and 12.
All right.
Okay?